In the world of network operations, being able to swiftly diagnose and resolve issues is crucial. Chapter 7 delves into observability and troubleshooting, equipping you with the tools to tackle real-time outages with finesse. When servers go down and networks falter, your ability to observe and analyze becomes your most valuable asset. Through mastering techniques like packet capture, log interpretation, and request tracing, you'll emerge ready to handle incidents like a seasoned pro. So, let's dive in and uncover the secrets to decoding network mysteries efficiently and effectively. Ever felt like finding a bug in your complex app was like searching for a needle in a haystack blindfolded? That's the challenge of modern distributed systems. But here's where observability steps in. It's like giving your system a set of eyes and ears that can pinpoint issues fast. With observability, you can track every packet, catch errors in the act, and spot delays before they escalate. Say goodbye to downtime that lasts for hours. Good observability cuts it down to mere minutes. So, why does observability matter? Because it transforms chaos into clarity, helping you keep your digital world running smoothly. Ever wondered how to truly understand and optimize your system's performance? Enter the 3 pillars of observability. Traces: follow a request from start to finish, pinpointing bottlenecks in real time. Metrics: track system health with numerical data, from CPU usage to error rates. Logs: dive into detailed event records, uncovering insights from error messages to user actions. Together, these pillars provide a comprehensive view of your system's inner workings. Master observability to elevate your system's efficiency and reliability. Imagine having a powerful tool that lets you peer deep into the inner workings of your network, revealing the secrets of data communication in real time. That tool is PCAP, Packet Capture. With it, you can capture and scrutinize every single packet traversing your network, akin to using a microscope on network traffic. Witness the data flow, destinations, and formatting with unparalleled clarity. It's like having X-ray vision for your network's communication. Unveil the mysteries of your network traffic with PCAP. Ever wondered what PCAP is? PCAP, a standard library, captures real-time network packets, utilized by tools like TPDump and Wireshark to record network traffic. When running a packet capture, you're essentially copying every packet passing through your network interface, each containing headers and payload data. Ideal for debugging connection issues, analyzing slow requests, detecting security threats, and understanding protocol behavior. Key tools include TPDump for command line analysis, Wireshark for GUI-based inspection, and Shark as Wireshark's terminal counterpart. Dive into the world of network packet analysis with these powerful tools. Ready to dive into the world of packet capturing with TPDump? Let's start with the basics. First, capture all traffic on interface S0 with a simple command. Need to focus on a specific IP address? Filter by host to isolate relevant packets. Want to zero in on HTTPS traffic? Use the port filter for precision. And don't forget to save captured packets to a file for further analysis. With these essential TPDump commands, you're equipped to dissect network traffic like a pro. Ever wondered what happens after capturing packets? Well, it's time to dive into the world of interpreting packet captures. Each packet is like a Russian doll, hiding layers of information within Ethernet, IP, TCP/UDP, and application protocols like HTTP. Uncover the secrets within by focusing on key elements: source and destination IPs, protocol and port numbers, sequence numbers, flags like SYN, ACK, FIN, RST, and the valuable payload data. And remember, Wireshark is your trusty guide, color-coding packets for easy identification, green for successful connections, red for errors, and blue for DNS queries. Master these visual cues to swiftly pinpoint and resolve issues. Packets hold the key, unlock their secrets for network success. Ever wondered how to tackle network issues like a pro? Picture this: you're faced with connection timeouts or sluggish responses. Step 1. Pinpoint the problem. Next, capture targeted traffic with precision, no data deluge here. Analyze for anomalies, retransmissions, delays, or odd responses. Craft a hypothesis on the root cause. Then, put it to the test and watch as your fix takes hold. Remember, a systematic approach pays off. So, diagnose, dissect, and deftly resolve. Unravel the network mysteries with finesse. Ever wonder what's really going on inside your applications and servers? While packet captures give you a peek at the network layer, logs and metrics dive deep into the heart of your system. Logs meticulously document every event, errors, warnings, actions, all laid out for you to analyze. Metrics, on the other hand, offer a big picture view, showing you CPU usage, request rates, error percentages. Together, logs and metrics create a comprehensive view of your system's health. Think of them as the heartbeat and vital signs of your digital infrastructure. With logs and metrics, you can not only see what's happening but also understand the overall well-being of your system. Ever wondered what valuable insights lie within system logs? These digital diaries capture pivotal moments: a login, a query misfire, a successful API call. Picture this: a timestamp marking the event, a severity level shouting error or whispering info, a message detailing the drama, and context revealing the players. Where do these tales reside? Some in the depths of /var/log/ on Linux, others in application-specific files, or perhaps within the vaults of Elasticsearch or Splunk. Imagine a scenario: a chilling error message from the API server, screaming of a database timeout. Utterly transparent, it reveals the timing, the culprit, and the victim. Dive into the depths of logs, uncover the power of precision in debugging. Ever wondered how to measure the performance of your system effectively? Let's dive into the key metrics that can provide valuable insights. Latency, the time taken for requests to complete. Forget averages, focus on P50, P95, and P99 percentiles. A high P99 could mean some users are facing a nightmare. Throughput, keep an eye on the number of requests your system handles per second. Sudden drops signal trouble brewing. Error rate, the percentage of failed requests. A surge in errors is a red flag. Set alerts for abnormal rates. Resource usage, monitor CPU, memory, disk, and network utilization. High usage can lead to performance hiccups. Remember, saturation at 100% spells trouble. Keep these metrics in check, and your system will thank you. Ever wonder how to keep tabs on your system's performance in a flash? Just take a peek at this metric dashboard. Up top, the request latency graph reveals latency trends, with a noticeable spike at 2 p.m. signaling user slowness. In the middle, the error rate graph reflects failed requests, mirroring the latency spike. And at the bottom, the CPU utilization section shows a sudden surge to 95%, pinpointing server overload as the likely culprit for the latency hiccup. See how these metrics tell a clear story of what's happening under the hood. Combining logs and metrics unlocks a powerful diagnostic duo. While metrics signal issues, logs pinpoint the root cause. Picture this: steady traffic metrics suddenly clash with a 5-second latency spike and a CPU screaming at 95%. Error rates skyrocket to 15%, unveiling pesky database timeouts. But fear not. A swift investigation unveils a sluggish query hogging CPU resources. With a quick tweak, harmony is restored, and metrics dance back to normal. By merging metrics and logs, the team sliced through the chaos, solving the puzzle in just 30 minutes. A lesson in efficiency. Ever wonder how to pinpoint the bottleneck when a user request slows down in a complex system? Enter latency tracing. In today's distributed systems, a single request can traverse over 10 services before yielding a response. But when things drag, how do we uncover the culprit? Distributed tracing is the key, a method that meticulously tracks requests from start to finish, gauging latency at each juncture. Picture this: a digital detective following the trail of a sluggish request through a labyrinth of interconnected services. Each step revealing crucial insights into where time is slipping away. It's like shining a spotlight on the shadowy corners of your system, illuminating the exact points where delays lurk. With distributed tracing, mysteries unravel, and performance optimizations become crystal clear. And remember, in the intricate web of modern distributed systems, where one delay can ripple through the entire network, tracing latency is not just a tool, it's a necessity. Ever wondered how distributed tracing works? Each request receives a unique trace ID, guiding it through your system. As it travels between services, each one creates a span, capturing when it received the request, the tasks completed, time taken, and response sent. These spans knit together to form a complete trace, illustrating the journey of the request. Tools like Jaeger, Zipkin, and Datadog visualize these traces, highlighting slow services in waterfall diagrams. With distributed tracing, every step of a request's path is meticulously documented, providing invaluable insights into system performance. Ever wonder what goes on behind the scenes when you load a web page? Let's dissect a trace from a user's journey. Each span represents a service at work. The front end takes 50 milliseconds to render the page and make an API call. The API gateway handles authentication and routing in 20 milliseconds. The user service, responsible for fetching user profiles, lags at 300 milliseconds. The content service spends 150 milliseconds retrieving personalized feeds, while the cache service quickly checks for cached content in 10 milliseconds. Altogether, the response takes 530 milliseconds. Surprisingly, the user service accounts for 56% of the latency. Investigating further, a missing database index was the culprit. By rectifying this, the user service latency dramatically reduced to 30 milliseconds, slashing the total response time by half. Remember, optimizing crucial components can significantly enhance overall performance. How can you ensure seamless tracing in your system? Every service should pass the trace ID to downstream services to maintain visibility. Consider using standard headers like xTraceID or embrace OpenTelemetry for automatic propagation. Remember, sampling wisely is key to managing data overhead. Capture a percentage of traces, but prioritize errors and slow requests for debugging. Enhance your spans with relevant metadata like user IDs and query details to better analyze slow requests. Lastly, set clear latency budgets for each service to monitor performance effectively. Alert when spans exceed their designated thresholds consistently. In summary, efficient tracing hinges on proactive propagation, strategic sampling, enriched context, and defined latency expectations. When production breaks at 3 a.m., all the observability tools in the world won't save you. What you need is a battle-tested incident response workflow that swiftly guides you from alert to resolution. Let's dive into the complete incident response lifecycle. Picture this: your system crashes, alarms blare, and chaos looms. How do you navigate this storm? By following a structured, efficient process that minimizes downtime and ensures a speedy recovery. From initial detection to post-incident analysis, every step counts towards restoring normalcy. In the world of incident response, a well-oiled workflow is your beacon in the dark. In the midst of a crisis, the incident response process kicks into gear. First, detection, whether through alerts or user reports, the issue is identified. Triage follows, determining severity and impact, guiding the path forward. Next, investigation delves deep, using data to uncover the root cause. Mitigation swiftly follows to contain the damage. As resolution takes shape, a lasting fix is implemented. Finally, the postmortem, lessons learned are shared, fostering a blameless culture. Each step crucial, each action deliberate, ensuring a robust response every time. As we wrap up, remember these key takeaways: master your tools by honing your skills with PCAP, logs, metrics, and tracing. Speed matters, efficient observability reduces downtime and MTTR. Layer your approach with the right tools for each issue. Learn from failures, each incident is a chance to grow. For your next steps, try capturing packets with TPDump and delve into a metrics dashboard. Embrace curiosity when things break, it's how you become a better engineer.